Okay, welcome to a walkthrough of Mastery Exam EL Practice Version 1, Problem 2. And this is the first problem on your Mastery Exams you encounter if you do them in order that has multiple parts to it, this 5-part question. All these parts have to do basically with the same couple or 3 ideas about logarithms here. So we're going to do all 5 of these in the same video. What is that main idea? Well, as you can see from the problem statements, these are all about finding the exact value of certain expressions that involve logs. So that means we have to come up with an actual whole number or fraction here. We can't use technology on Mastery Exams, and so we have to use something else, something we know about logarithms in order to do this. So let's review what the basic rule is. Well, over here in the right part of the screen here, I'm going to write down the basic definition of what a logarithm is. If we say that the logarithm base A of x equals y, what does that mean? That means the same thing as if I said a to the y equals x. That's a basic definition. You should remember or try to memorize this definition if you can. So when it says log base A of x equals y, that means the following. It's kind of a schematic. That means a to the y power equals x. A to the y power equals x. And then further down here, in these two, we're going to use a different rule. I'll just kind of put this over here to the side. That would say that the natural logarithm of e to the anything is a, and e to the natural logarithm of a is a. Those two things are known as the cancellation properties for the natural logarithm. So we're going to keep these two things out. Let's box them up in red so we'll have them handy and know where to look. This and this. And now let's proceed to use these in the first part of the problem we have to do here. I'm just going to go down here and label this A. And we're supposed to find the exact value of the log base 2 of 64. Now what does that even mean? Well, let's call it y. I don't know what that is. But whatever it means that 2 to the y power equals 64. So I'm looking for a number, y, such that 2 to the y power is 64. Now, I can probably start guessing at these because we don't make these master exam problems to have really strange answers. I know that 2 to the second power is 4, 2 to the third power would be 8, 2 to the fourth power is 16, 2 to the fifth power is 32, and 2 to the sixth power is 64. Okay, and so that is what my y is. It's the power that I place on x, on 2, I should say, to get this answer. So I'm going to put that up here in the blank just as I would on the master exam itself. So the log base 2 of 64 is 6 because, again, change colors slightly here, because 2 to the 6th power is 64. Before going on to B and C, if that doesn't make sense to you, or if that's kind of a new idea for you, is pause the video and just think about this and maybe try a few examples of your own out and use your graphing calculator or computer to get the answers. Just make sure that you understand how this definition is being employed because it's essential for all 3 of these first parts. Go ahead and pause if you need to. I'll be here when you get back. Okay, you're back, so I'm assuming that you've gone and reviewed, or at least intend to review, those basic logarithm rules. Let's put it to use again in part B. I'm asked to find the exact value of the log base 10 of 0.1. Just for clarity here, let's remind ourselves that 0.1, of course, is the same thing as 1/10. Okay, so what am I looking for here? I'm looking for a power on 10. I'm looking for the power I would place on 10 to get 1/10. Finding the exact value of log base 10 of 0.1 is the exact same process as finding the solution to this equation. 10 to the what to the y equals 1/10. And when you get it to that point, in mastery exams, they're constructed so you should just be able to think through what that answer might be. What do you raise 10 to get 1/10? Well, thinking back to your exponent laws, you might remember, or hopefully you do remember, that if I take a number and raise it to a negative nth power, that's the same thing as 1 over x to the nth. Negative exponents create fractions, and that's exactly what I have here. In fact, I have 10 to some power equals 1/10. So 10 to the what power equals a tenth? Well, I know that 10 to the negative 1 power equals 1/10. So that tells me that y equals 1. And so that's my answer. the exact value of log base 10 of 0.1 is minus 1. Because, again, 10 to the negative 1 power is 0.1, or 1/10. If you're still having trouble understanding that, you might just want to pause the video again, work back through that example, do a little Google search on exponent properties and logarithm properties, and see if you can work a few more exercises out. Let's go ahead and finish this first part of this mastery exam, get rid of that, by looking at part C. Same kind of question here. I'm asked to find, oops, I'm in the wrong color. Same kind of question here. I'm asked to find the exact value of the log base 8 of the square root of 8. Okay. Now it helps to rewrite this as an exponent, because that's how we did. We were thinking through exponents here. So radical 8 is the same as 8 to the 1/2 power. That's another exponent property. We went over that property actually in the walkthrough for problem 1 on this mastery exam. So if that's a new property to you, or you can't quite remember it having seen that before, remember to go back and look at the screencast for problem 1. So now think to ourselves, what power do I place on 8? What power do I place on 8 to get 8 to the 1/2 power? Well, it shouldn't take you too much thought to think like, well, it has to be a half. That's the power, and that's the value of the logarithm. So the exact value of the exact value of log base 8 of square root of 8 is 1/2. It is the power such that if 8 to the 1/2 power, that's radical 8. So that's the first 3 parts of this problem. Let me erase the work here. Again, this being a video, you can pause and rewind and review at any time you wish, so don't feel like you're being run off and left here. Now let's talk about these last 2 that involve the cancellation property. Here I'm given, in part D, I'm given to find the natural logarithm of e to the 2/3. Well, this looks like a job for this first cancellation property, which just basically says that the natural logarithm of e to any power is the power. And so there's almost nothing to write here. The natural log of e to the 2/3 will just be 2/3. There's a cancellation that takes place. And so in this blank, I will just simply put 2/3. And lastly, I don't think I'm going to write this out here, the other cancellation property would say that e to the natural log of a, any power, is the power. And that's the situation I'm in e. E to the natural log 5 is 5. So those last 2 are pretty simple if you know the cancellation properties. That's really what those last 2 problems are all about. And then the first 3 are really important because they involve this definition of the logarithm. Again, the log base 8 of radical 8 is a half, because 8 to the 1/2 is this, radical 8. And the log base 10 of 0.1 is -1, because 10 to the -1 is 0.1. And likewise, log base 2 of 64, let's get rid of this all these decorations here, log base 2 of 64 is 6, because 2 to the 6th is 64. You get those log rules down, you're going to be in much, much better shape when we start using logarithms in calculus. And please don't be afraid to ask for more detail and more clarification on this idea of logarithm rules at the Math Study Center or in office hours.